saying to Austin, we're going to do algebra today. He went, I won't be able to help you because I'm not sure what that is. So Austin's putting himself into a kind of, he's taking himself outside the comfort zone today. So, but I'm sure with the explanations, he will get it too. So let's get started then. Oops. So here we're going to find out today, algebra is nothing new. You're already doing it. You just don't know. So we're going to understand how to, so there's kind of level 1, which is P2 to P4, and level 2 to P4 to P6. We're going to look at using the term less than, greater than, equal to, not equal to, and solve some simple algebraic problems where a symbol is used. And level 2, we're going to look at equations. So this sign here, that's the equal sign, and it just means equal to. Nice and easy, isn't it, Austin? It's nothing new. And this sign here, the equal sign with a line through it, just means it's not equal to something. So nice and simple. So here, how many yellows are there, Austin?
3.
How many reds are there, Austin? Is that equal to each other?
Yeah.
So 3 here, 3 here. The 3 yellows are equal to the 3 reds. So in the middle here, we put 3 equals 3. Make sense?
Yeah.
Yes. How many yellows, Austin?
3.
How many reds, Austin?
4.
Is that equal to each other? No. So we've got 3 here, we've got 4 here. The 3 yellow is not equal to the 3 reds. So what we put in there is we put an equal sign with a line through it. So that means it's not equal to each other. And we'll do the same with it, the numbers down below. So 3 is not equal to 4. Get it? Yep. So how many yellows do I have?
3.
How many yellows altogether?
Oh, 6.
So I get 3 plus 3. Does that equal the reds over here? So 3 plus 3 is equal to the 6 reds, isn't it? So I can put a wee equal sign here. So 3 plus 3, in fact, equals 6. Does that make sense? Yep. Does that make sense at home? Yeah, you got something to say? What?
But Steve, you said that was the same as each other. It wouldn't be because they're different colours.
Different colours, but I'm talking about the amount is equal, isn't it? Yeah.
It's the same.
Yeah. Okay. How many yellows do we have? Austin?
8.
We've got 4 plus 4, which is 8. How many reds do we have?
8. 5. 10.
10. Is that equal to each other? No. So 4 plus 4 or the yellows is not equal to the reds. Does that make sense? So we can put that equal sign with a line through it, which means it's not equal. We can say 4 plus 4, there's 10 over here. 4 plus 4 is not equal to 10. Does that make sense? Is this making sense at home? So the equal sign and the not equal sign, very simple. If numbers or the quantities or the amounts are equal to each other, we use the equal sign. If it's not equal to each other, we put the line through the equal sign, which means it's not equal. Good, I hope that's making sense. So, using only the equals or not equal sign, insert the correct symbol. So, at home, do you know what 2 plus 7 is? At home, do you know what 3 times 3 is? What sign can I put in the middle here? Can I put equals or can I put not equal or not equals? Do you know, Austin? What is it?
Not equal.
Not equal.
Oh, I thought it was 3 plus 3.
Okay.
Equal.
Because it's 3 times 3, which is 9. 2 plus 7, which equals 9. So yes, we can put an equal sign in here because it's 3 times 3 and 2 plus 7. The answer to both are 9. So 2 plus 7 equals 3 times 3. So in here we put in the equal sign. Let's try this one then. So 4 times 5, work that out at home. 31 take away 12, work that out at home. And using only the not equal or equal sign, insert the correct symbol. So is 4 times 5 equal to 31 take away 12 or not equal to 31 take away 12? Do you know the answer at home? If you do, type in the answer into the box or just shout it out so that your parent knows. Austin, are you going to tell us, is it equal or not equal? Not equal, because 4 5s are
20.
31 take away 12 is
19.
So 4 times 5 does not equal to 31 take away 12. Okay, so as normal, we have tasks for you to do. So you can go to this web address, countonus.org.uk/learning-together, and you go to session 7 and hit the task button. There is some tasks for you to do on algebra, just like the ones we just did. And obviously there's lots more, so I'm not going to dwell too much on that. You can try that later. So we've got to learn about another sign. So we're going to learn about less than. Good. What does it mean?
Basically, if you had two numbers right next to each other, if the one was less than that sign would turn to that sign would be like open, like the opened up bit of that sign would be at the bigger number.
That explanation. And that sign means more than, doesn't it?
Okay.
So let's look at some examples. How many yellows do we have?
4.
How many reds do we have?
3.
So what's the bigger number?
4 yellows.
4 yellows. 4, what would you say? 4 is what then? So let's put 4 there and 3 there. Is 4 bigger than 3, or is 4 more than 3, or is 4 greater than 3, or is 4 less than 3? What do you think?
4 greater than 3.
So 4 is greater than 3 or more than 3. So I can write that in there. 4 is more than 3. And the sign we use, if you look back here, the sign for more than, is that one there. So it goes that way. And Austin's saying, his explanation here, which I never thought of before, is the open bit. So this bit here is beside the bigger number. Okay, I like that, Austin. So 4 is greater than 3, or 4 is more than 3. So that is the more than sign. How many yellows do we have?
3.
How many reds do we have?
4.
3, 4, and 3 is
The less than 4.
good. So 3 yellows is less than the 4 reds. So 3 is less than 4. So the symbol goes this way this time. And again, Austin's saying the open bit here is kind of beside the bigger number.
Less than doesn't have a 2.
Okay, now we've got 2 and we've got 5. So 2 is something than 5. So we're going to use one of these two symbols only. So 2, is it more than 5 or is it less than 5? What symbol am I going to use? What do you think? What symbol am I going to use? You can type into the chat box. If you're on if you've got a keyboard, you can type in the same. What sign do you think it's going to be, Austin?
I think it'll be on 2's side.
Yeah, so what sign we're going to, yeah, the green or the red one. The top one, you think so 2 is bigger than 5?
I thought you said 2 is less than 5.
Yeah, that's so what sign is that?
There's a that one.
Yeah, good, the red one. So 2 is less than 5. Okay, so this is what we're doing. We're putting in the right symbol. 2 is less than 5. So we'll try the next question. 6, something 4. So what sign is missing in here? Is it the more than sign or is it the less than sign? So 6, what something than 4? What sign is missing? Is it more than 4? Is it less than 4? What do you think, Austin?
More than.
Good, so it's this sign here, so I'm going to put that one in. So 6 is greater than or 6 is more than 4. Okay, let's try the next one. So this time we've got a recalculation to work out. So 2 plus 3, and there's something missing, 4. So 2 plus 3 more than 4, or is it less than 4? What do you think at home? So 2 plus 3, is it more than 4? Is it less than 4? What do you think, Austin?
More than.
Good, so it's this green symbol here, so I'm going to take that up here. And 2 plus 3 is greater than 4, or it's more than 4. Another calculation to do, so we've got 10, then a sign is missing. 10, something 2 times 6. 10, something 2 times 6. 10 is?
Less than.
Good, less than. So the less than sign is this one here. So 10 is less than, because 2 times 6 is? 10 is less than 12. Okay, now this time we've got 2 calculations to work out. So what do you think? What sign goes in here? So you can type in or write in what sign do you think goes in. Is it more than or is it less than? What do you think, Austin?
More than.
3 times 5 equals?
15.
2 times 6 equals?
12.
So 15 is more than 12, so we use the more than sign. And again, also is talking about the open bit of this sign is beside the bigger number, which I never thought of that before. Okay, last question I think we're going to do here. So 29 plus 15, what sign goes in here for 50 subtract 4? So we need to work out 29 plus 15, we need to work out 50 subtract 4. What sign do you think goes in there, more than or less than? Okay, what do you think, Austin? Less than. 29 plus 14 is 44. 50 subtract 4 is 46. So 44 is less than 46, so you're right. And it's good to look back on some of the other strategies we were doing for addition. Remember, one of the strategies that we did for addition way back in session 2 was to add on 15. I would split the 15 up into 1 and 14. The reason I would do that was to make a total 10. So 29 plus 1 is 30. So it's good to talk about the different strategies you might use for this here. How are we getting on at home then? Are we understanding the more than and the less than sign? I'll just stop right now just to see if I've got any messages coming through. Let's see.
Daddy said 29 plus 14.
I might say 29 plus 1 is 50. Right, I think we're okay for questions just now. Right, good. So, let's see what's next. So, using only the less than or greater than sign, insert the correct symbol. So what do you think? What symbol goes in here? 2 times 9 and half of 40. What sign do you think goes in? So you put in the chat box, what do you think goes in here? What sign do you think it is, Austin?
The greater one.
You think so? What's 2 times 9?
18.
What's half of 20? Half of 40?
20.
So do you think 18 is greater than 20? So 2.
Oh, that goes the other way.
Yeah.
Okay, and less something.
Good, it's the less than sign. So 2 times 9 is 18. Half of 40 is 20. So 18 is less than 20. Right, I think I'm going to skip by this one just now because that's enough tasks. So again, there's more tasks for you to do here on this slide here. Okay. So, algebra. We were talking before we started this session about we're going to kind of show you how algebra starts down at the kind of primary 2, primary 3 kind of level. And this is where it starts off because basically all you're doing here is working out the unknown. So how many yellows do we have here? We can see, I've told you there are 7 yellow cubes altogether. How many are under the red flag? So basically what we're doing here is we're saying 4 plus, now this just stands for a missing number, equals 7. So 4 plus this missing number equals 7. And again, we can show you using pictures, or we can show you using, you could use cubes or something to model this. So if I move the flag, we can see it's 4 plus 3 equals 7. So that missing number there is 3. So that there is algebra down at the very kind of basic level. We're not using letters just now, but we're just kind of using the number, using a wee symbol to represent the missing number. So here we've got 10 yellow cubes altogether. How many are under the red flag? So again, if I introduce a kind of wee algebraic statement, 10 equals question mark plus 6. So 10 equals question mark plus 6. So again, I've told you there's 10 cubes underneath the both flags. So what must be under here? It must be 4. Good. So again, this is algebra you're doing. You might not know it's algebra, but you're working out the missing number. So the missing number here, the question mark, is 4. So that is algebra down at the kind of basic level. Here's another algebraic question, but it's just filling in the missing number. So this is how algebra starts. It's just filling in the missing number. So 6 is equal to 8, take away something. Now, some of you might know that already. Do you know it already, Austin? Tell the answer. No. So 6 is equal to 8, subtract something. So what do I'll show you what I mean. So 6 is equal to, here is 8. How many do I need to cross out so that these two are equal to each other?
2.
2. I need to cross out 2. So the number that goes in here is?
2.
And we can just check that. What's 8 take away 2?
6.
6. Understand what we're doing? Yeah? So all we're doing here is just putting in the missing number so that we get the right answer of 6. So 8 take away 2 equals 6. So therefore, when we see a question like this, all we have to do is put in a number here so that we get the right answer. Okay, let me just go on to the next one then. So 12 plus a number equals 18. So we're filling in the missing number. 12 plus what equals 18. So this is us doing algebra right now. Don't tell the answer, Wilson. Do you know the answer? Yeah? So 12 plus something equals 18. Now we can model this out. A lot of the times when we do algebra in the earlier years, kind of P2 to P4 is we just have a kind of box where we put the missing number in. But if I draw out 12 dots or get out 12 counters and I say what do I need to add so that it equals 18, you can see here how many red dots do I have to add on here, Austin? 6. So therefore 12 plus 6 equals 18. So in here I write the number? 6. Good. So 12 plus 6 equals 18. So again, that is just you completing some early algebra work. Now here, sorry. So this may be the way you're introduced to algebra. So 12 plus, now this empty box, we just put a number in there, equals 18. It is absolutely nothing different. So that's what I'm talking about. It's nothing new. So the new way to write this when we start talking about algebra is we write 12 plus x equals 18. But x just stands for 6. It's just a number. So this question here is exactly the same as that question there. If you know how to do that, you know how to do that, Austin? Mm-hmm. Then you know how to do that there. That's an algebraic equation. 12 plus x equals 18. What is the value of x? And you know that it is 6. So if you can do that, you can do that. What are you going to tell us?
Can you use any other letter?
Yeah, you could. Also, that's a good question. Yeah, you could use any other letter there, and we will look at that as we go on. You could use Y, you could use D, you could use A, you could use B. Most commonly in maths, X is the most common used number, but yes, it can be absolutely anything. So algebra is nothing new. If you know how to solve that, you know how to solve this. Right, let's look at some more questions. So here, something take away 2 equals 7. So I want you to think about that. What number, if I subtract 2, equals 7? So what number, if I subtract 2, equals 7? Do you know the answer, Listen? Don't tell us, okay? Another way of writing that is saying x subtract 2 equals 7. But you're just thinking, what number do I subtract 2 from that equals 7? So x minus 2 equals 7. So what must this number x be? It must be
9.
Good, because 9 take away 2 equals
7.
7. So it's nothing new that we're doing algebra. So I want you to get that in your head. Anytime we're doing algebra, it's nothing new. We can think of it as just working out the missing number. So it's 9. So in this case here, if we were solving the algebraic equation, we would say x equals 9. If you were doing it like that, you would just put in 9 into the empty box. 5 times something equals 15. So again, this is an algebraic equation, or filling in the missing number. Do you know what the missing number is at home? If you do, type it into the chat box. What is the missing number? Do you know the missing number, Austin? Yes or no, don't tell us. Austin thinks he knows it. So another way I could write this, and Austin would write earlier on, we can use any letter. So I could say 5 times 8 equals 15. It's the exact same question as it is above. 5 times a equals 15. Do you know what number goes in here, Austin?
Yeah.
What is it?
3.
5 times 3 equals 15. That's straightforward, isn't it? Same here. 5 times a equals 15. We're solving the exact same problem. Where a stands for a number, and you know that 5 times 3 is 15, so a must equal 3. So that's you solving an algebraic equation. If you can solve that, then you can solve an algebraic equation. Nice and easy. It's nothing new. Okay, I'm just going to stop just for a second. There is no questions coming through, so that's good, but we like questions. So please, if you have anything at all that's bothering you, type something into the chat box and let us know. Okay, here's another way we can write it. Obviously, 14 equals a times 7. So I want you all to think about that at home. 14 equals a times 7. Do you know what the letter A is? What is the A member stands for a number, okay? Well, the question would be solve or work out the missing number, work out the number A, what it represents, what it stands for. What is it, Austin?
2.
Are you sure?
Yeah.
Good.
Yeah.
Again, the other way of thinking it, or you may have been introduced to it, is 14 equals this, or this missing number times 7, and it's nothing new. Austin says it's 2, so A equals 2. Nice and easy, nice and straightforward. So here we might get something like this: solve x plus 2 equals 8. It's nothing new. All it means is something plus 2 equals 8. What number goes in here then? Think about that at home. What number goes in here? Do you know, Austin?
Yeah.
What is it?
6.
Austin thinks it's 6. So you might know it's 6, but here is a nice way where I like to demonstrate how to solve equations. Now, you might know the answer 6 here, but this is a nice way to look at it. So I'm going to use counters here to model it out. So this blue counter represents x, and I have to add 2. So I'm going to add a 1 and a 1. Is that 2?
Mm-hmm.
And that equals 8. So this blue line, that's going to stand for the equal sign. That's equal to 8. So I'm going to put 8 counters over this side. So here I'm trying to use, this is me trying to demonstrate how to do algebra if you're using counters and so on. So I can see here I've got x, which is this bit here, plus 2, so I've got 1 and 1, which is 2, equals, the blue dotted line standing for equals, that equals the other side, which is 8. Now, I want to work out what x is, so what I want to do is I want to chop that one off and chop that one off. But how many have I chopped off here?
2.
So if I'm chopping off 2 from this side, I need to do the same to the other side, I need to chop off 2 from that side. So I'll chop off 2 there, chop off 2 there. Now, what I'm trying to do is I'm balancing. So we're saying, okay, now I've chopped off those 2, let's just rub them out all together. And I can see now that x is equal to 6. So it's another way of looking at it. Rather than looking at just thinking of what's the missing number over here, we can actually use counters to model out an algebraic equation. So we count out our x plus 2, we count out our 8, we cancel, or we say, right, well, I don't want these 2 1s here, so I cross it out and cross it out. Because I crossed out 2 from this side, I need to cross out 2 from that side, and we get x equals 8. Or sorry, x equals 6. Another way to do it is you could draw a bar. So we're going to look at a wee bit of bar modelling on Thursdays, but it's a nice wee introduction. So I could write a bar out at x and a bar out at 2, and that is equal to 8. So I'll draw a bar out at 8 below that. But out of this, we know this bit here is 2, don't we? So we're trying to work out what this bit here is the x. So if I bring that 2 down there, this bit here must be what the x is, isn't it? And what number plus, if this is to equal 8, what must this blank bit be here? 6. So another way to look at it visually is to draw out a kind of wee bar model of it. So we'll get our x plus our 2 is equal to the bar that's 8. But I know this wee bit here is 2, so this remaining bit must add up to 8, so that bit must be 6. So it's just another way to kind of visualise the algebra part of it. We might have something like solve 2x equals 10. So I'm going to put 2x on this side, and I'm going to put 10 on that side. I'm going to just move that x down to try and match it up. And I'll move these 1s down to match it up. So if I've got 2x equals 10, I can say this x matches that and that x matches that. So x equals
5.
Good, 5. And again, it's just like thinking 2 times what equals 10. Or another way of model it out is say I've got an x and an x, I've got 2x, that equals 10, doesn't it? But what I have to do is I have to say, right, well, I'm going to split this 10 into 2 bits to work out what it is. So I split the 10 into 2 bits and I can see it must be 5 and 5. So x equals 5. So again, these are just other ways to kind of model the subtraction, model the algebraic equation. Hopefully it's making sense. So here, solve 3x equals 12. So what I'm going to draw is I've got 3 x's and I'm going to put 12 on the other side. So I have 12. Now I'm going to try and match them up or kind of spread them out evenly between the 3 x's. So I want you to think in your head, if 3x equals 12, what is x equal to? So I'm going to move these round about and I'm going to match them up together. So I'm going to split them evenly or split them fairly. So what do you think x equals, Austin?
4.
Good. So we split the 12 counters between the 3 x's, and again I'll show you this in the bar model. So we've got x, 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 we've got 3 x's, and that is equal to 12. So we can see I need to split this 12 between the 3 x's, so x is equal to 12 divided by 3, and that must be 4, 4, 4. So we can see x equals 4. So another way to look at the equation. Or again, you might be thinking of it as 3 times what equals 12. Obviously, with this fact here, you can always important to relate to other facts. 12 divided 3 equals 4. That's because 4 3s are 12, or 3 4s are 12, and also 12 divided 4 equals 3. And a third of, you might think of a third of 12 equals 4. So always important always to relate to your other mathematical facts as well here. Right, I'm just going to stop because that's quite a lot of stuff we're going through. No questions coming through? Sure nobody wants to ask any questions? We're ready to answer them? Nope. Okay, let's go then. Okay, so let me just see here. Right, so next what I want you to do is I'm going to ask you to type in what you see on the screen. What do you see on the screen? Type into the chat box, please, for me. What do you see on the screen?
5 ones.
5 ones. So what's the total here?
5.
5. So it's 5 ones. That's because I've got a 1 counter on it. So here we see the total is we've got 5 ones, so the total equals 5. Yes? What do you see now? Type into the chat box, what do you see now? What do you see?
-4.
-4. So we've got 4 minus 1s. So the total is -4. So algebra involves a lot looking at negative numbers, and we'll see why in a second. So what I want you to do now is tell me what you see now. So don't say anything just now, Austin. Let's give everybody a chance to see what they see. What do you see on the screen now? What do you see, Austin?
1 minus 1.
Yeah, 1 and a -1. What were you going to say there? You started going, you said
0.
0. You see 0. Explain to me why you see 0.
Because if you have 1 and then you minus 1 away from it, it's 0.
Okay, so 1 minus 1 is 0. So if we've got a 1, a positive 1 and a -1 next to each other, or here, what's the total? So I've got a positive 1 and a -1. So all of the previously we had 5 ones, which was total 5. Here we had 4 -1s, which is a total of -4. Here we've got 1 and a -1, and the total is 0. Total equals 0. Yeah. Now I'm going to call that. This is referred to as a 0 pair. Okay, so these two pair up to make
a 0.
Yeah. So these are this is referred to as a 0 pair. Now I want to look at the screen now, everyone. tell me what you see. Think. You can type the answer into the box. You can shout out, what do you see here? What do you see? So I see 5 positive ones and 3 negatives. Give me a second. What do we see here? So hopefully you see 5 positive ones and 3 negative ones. What's the total? No, the total, Lawson? What is it? 2. Lawson says it's 2. If I just put them together, I can see that's a 0 pair, that's a 0 pair, that's a 0 pair. So they all cancel each other out. So I'm just left with these 2 at the bottom. So I'm left with a total of 2. Good. Let's try the next one. Hope everybody got that okay. So you might actually, you could at this point say, well, 5 add on minus 3 gets your total equal to 2. Okay, look at this one, everyone. Tell me what you see. So what do you see here? What do you see, Austin?
I see -4.
You see -4. Let's go with this then. So I've got 3 1s and I've got 7 -1s. So here, that's a 0 pair, that's a 0 pair, that's a 0 pair. We can disregard these, and I'm left with -4. The total equal is -4. How we got on in the chat box here? We all getting that okay? Yes. I'm just going to check, see if still no questions coming through. Good. It was either very good or I've just left us and we're speaking to no one. Right, okay, so we could understand that the total equals -4. Again, we could start off by looking at it was 3 plus -7, so we had 3 and a -7, so the total is equal to -4. Right, now the reason we'd spent all the time doing that is because we can show you how you can solve equations like this using counters. So x minus 3 equals 5, so I start with an x, and I've got -3, so I've got -1, -1, -1, and that's to equal 5. So here, this is a picture to represent this equation. Yes? I've got my x, I've got my -3 because I've got -1, -1, -1, and I've got equal 5. Now, I want to get x on its own, don't I? So I don't want these -1s here, I just want to know what x is. So one way to get rid of these -1s is if I add in 1, 2, 3 elements. Because I added in 3 to this side, I need to add in 3 to that side, because we're balancing the equation. We want both things still to be the same. But we can see here now, that's a 0 pair, that's a 0 pair, that's a 0 pair. So what do the 0 pairs do? We can they all equal 0, then we don't need them, do we?
No.
So I can just disregard these, and I'm left with x equals, how many is over here now?
8.
Good. And again, you might think of that, you can say, well, 8 take away 5, sorry, 8 take away 3 equals 5, so yeah, I'm correct. Again, if we were looking at a bar model for this, we start with x. Now, if I take away 3, so if I take a bit 3 away from it, I'm left with 5. So that means 3, this 3 and this 5 gets you your total bit of x. So you can see, to find out what x is, you have to add 3 onto the 5. Right, we'll do one more of these. So x take away 5 equals 7. So I'm going to model this equation out. So, sorry, we'll just do it with the bars here then. So x take away 5 equals 7. So again, you might think you know the answer, what number take away 5 equals 7, but I can show you using this model here. So I'm starting with x. If I take off a bit that's 5, I'm left with 7. So if I start with a bit x and I take off 5, I'm left with 7. So that means if I put that 5 onto this bit here, we can see x is equal to this 7 plus this 5. So the answer is 12. And you can check always by substituting back into the question. So this says x take away 5 equals 7. So if I put 12 back in place of x, so we're putting 12 in instead of x, what is 12 take away 5? 7. So we must have got the question right. I hope that makes sense. Obviously, you can think of that in your head. Again, it's nothing new. If you just think what number take away 5 equals 7. But hopefully, using either these counters that we used or using this bar model, then we can see that it helps us determine what to do. Right, I'm just going to look at the question. Okay, yeah, we'll get time for this one. So x take away 8 equals 13. So I'm going to start with I want you to draw this bar x out. So draw that out for me, please. Now, if you take off a bit, that is 8. So start with that bar x. If you take off that bit here, 8, then it tells us up here, x take away 8 equals 13. So this bit that's left must be 13. So how do we work out x? Well, this bit here at 8 plus this bit here at 13, that gets us a total of x. So x equals 13 plus 8, so it's 21. So, no questions again. So, we are doing very, very well. Or we just don't want to ask questions. So, obviously, all our slides again and resources are at this web page here. And the hashtag is NPFS Maths. And obviously, we are on the slides will be on YouTube later on. You can follow us on Twitter and Facebook.
What was our first question?
No, I thought it was a question come through, but it's not. So thank you very much for taking part again. If you can complete this